Almost every machine you see around you, from electric motor to wind turbine, depends on one small but powerful component. A component so precise that even a tiny imperfections can cause massive failure. This is the bearing, but have you ever wondered how these high precision components are actually made? From raw steel to micron level accuracy, the process is more complex than you might think. In this video, we take you inside the factory to explore how bearings are manufactured step by step. Bearing manufacturing begins with the selection of high quality raw material. Most bearings are made from high carbon chromium steel, especially designed to handle heavy load, resist wear, and maintain strength under continuous rotation. The quality of this material directly affects the life and performance of the bearing. The steel is then cut into smaller pieces and heated to extremely high temperatures. Once the metal becomes red hot, it is shaped using powerful forging machine. This process forms the rough inner and outer rings and improves the strength of the material. After forging, the rings move to precision machining. CNC machines carefully shape the inner and outer surfaces, creating raceway where the rolling element will move. High accuracy at this stage is critical to ensure smooth operation and avoid vibration. The machine rings then undergoes heat treatment. They are heated and rapidly cooled in controlled conditions to increase hardness and wear resistance. This ensures the bearings can operate under high stress and high speed conditions. Next come grinding and super finishing, one of the most important stage in the process. The surfaces are polished to extremely tight tolerance, often within microns. This smooth finish reduces frictions, minimize noise, and improve efficiency. Meanwhile, the rolling element, usually steel balls, are manufactured separately. They are formed, ground, and polished until they achieve perfect roundness and a mirror-like surface. Even a small defect can affect the entire bearing performance. Once all components are ready, the bearing is assembled. The inner rings, outer rings, balls, and cage are carefully combined. The cage keeps the ball evenly spaced and ensures stable and smooth rotation. Lubrication is then applied using special grease or oil. This reduces frictions, control heat, and protects the bearing from wear and corrosion, significantly increasing its service life. Before final approval, each bearing undergoes strict quality testing. Parameters such as vibration, noise, rotational accuracy, and load capacity are carefully checked to meet industrial standards. Finally, the bearings are clean, coated with anti-rust protections and securely packed. These precision components are now ready to be used in motor, vehicle, turbines, and industrial machines around the world. Despite their small size, bearings play a critical role in modern engineering. Without them, machines would suffer from excessive frictions, energy loss, and rapid failure. From raw steel to precision engineering, this is how bearings are manufactured.